x minus y dy dx is equal to x plus y. And I want to just, not give any hints to it, but we're gonna play around with this and see what happens when we play around with it. That's, in my opinion, the best way to, learn how to solve any type of equation is just to be able to see it and see what you can do to it. How can you play with it to make it easier to solve? So first, I'm gonna divide by this side. So we're gonna get dy over dx is equal to x plus y, x minus y. Now that doesn't look that much better, but if we divide by x, so if we divide by 1 over x across the top and bottom, we'd see that we'd get 1 here, y divided by x, y divided by x. We know that we can set v equal to y over x. So let's do that. So let's do dy dx is equal to x over x plus y over x divided by x over x minus y over x. And that's going to be dy dx is equal to 1 plus y over x divided by 1 minus y over x. Now, let us, we did this over here earlier, so we're going to do v equals y over x, which means v prime is going to be equal to what? Well, we can solve for y, use v times x, and then solve for y prime, so we can substitute y prime in. So we're going to get y prime is equal to, well, we see that v is a function of x, right? And y is a function of x. So we must apply, right, the chain rule. We would say, so we're going to implicitly differentiating this. So we're going to take v prime times x, which is the derivative of v, plus, v times the derivative of x, which is 1. And that is the product rule applied, right? We have two functions, both of x, which x is just itself, but... Okay, so now let's substitute that in. So we're going to make our substitution color in orange. So we're going to get, dy dx is equal to this. We'll substitute this in. And I'll write dv dx, and that's times x, plus v is equal to this side of the equation. And we're going to substitute v in for those parts. 1 plus v, 1 minus v. Now, let's subtract v from both sides. So we're going to get dv dx times x is equal to 1 plus v, 1 minus v. And we're going to subtract v. Now, let's try to make this one fraction and see what we get. So we're going to get dv dx times x is going to be equal to, 1 plus v minus v times the denominator, 1 minus v, all over 1 minus v. So now let's take this and simplify it. So we're going to get, use a new color, we're going to get that dv dx times x is going to be equal to 1 plus v minus v plus v squared, 1 minus v. And we see that that's coming from, minus v times 1 is negative v, minus v times minus v, v squared. So let us now simplify this. dv dx is equal to 1 plus v squared, 1 minus v. And I forgot my x. So now let's I think we can solve this. I think if we split this up and then integrate, we'll be able to solve this. So let us divide by x and then times the both sides by the reciprocal of this. So we're going to get that the integral of 1 minus v, the reciprocal, over 1 plus v squared dv, and times both sides by dx, integral of 1 over x dx. So I'm going to do this portion right here. I get ln of x plus c. And now we're going to work on this part, which is going to be a pain. So let's do that. Let us use green. So we're going to get the integral. Well, let's split it. We're going to get 1 divided by this, and minus v divided by that. So 1 over 1 plus v squared minus the integral of v 1 plus v squared dv dv. So we see right here that we know that if we take d over dx of arc tan of x, we will get 1 over 1 plus x squared. Which means that if we integrate both sides, we can go backwards. So let us use this fact, and then let us go backwards. So we're going to get that this portion right here, and here is going to be equal to arc tan of y over x. Now, let us work on this part. So we can see that if we use u sub, and we set u equal to 1 plus v squared, we differentiate it, we can get rid of that. So let us integrate where we say u equals 1 plus v squared, which corresponds to u prime, equaling, well, let's see, this goes to 0, that's 2v dv. So we see that dv corresponds to du over 2v. So substituting that all into this equation, we're going to get, well, we're going to get v divided by u du over 2v. That's going to cancel out. We're going to factor out a 1/2. 1/2 the integral 1 over u du. Then once we integrate this, we'll get ln of the inside, which is going to be, this is going to be u is equal to that, 1 plus v squared. We see that this will never be negative, right? Because we have a 1 and we have v squared, you just take it a negative, it would be positive. 1/2 ln of 1 plus v squared. Now we just need to piece together all these parts. So we'll piece together the right side of the equation, which is right here. And it's going to be, where'd it go? Oh, ln of x plus c. It's going to be equal to, well, this part and this is negative. So we'll write that down here. We're going to get v squared plus 1 ln 1/2 minus y over x and that is the solution. Oops, and I did forget to substitute what v equals y over x. We see that's v squared, which is going to be y squared over x squared. And that is the solution to the differential equations. So much fun, so much fun. All right.